Well, good morning. The stream will be starting very soon, just in a few minutes, while people start to join the stream. There are some chat rules, but they should be very easy for today's stream. Just basically, try and keep it remotely related to programming or tech or retro stuff like that. Trying to keep the language polite and suitable for a family-friendly audience where possible. The chat rules are a little bit more strict this morning because it's 5 a.m. and I'm tired. If you want to be a bit more rowdy and controversial, you're welcome to do so on the Saturday stream when I'm actually half awake and can cope with it. So that's basically why we're doing that today. So today is going to be programming Yquest again, the Z80 game, which is currently for the Amstrad CPC, but will be ported to other systems later on. So if you're not an Amstrad CPC fan, I apologise a little bit for that, but as I say, it will be expanding out later on, so hopefully it'll still be interesting. And maybe it will come to the 650 to 68000 series later on. I can't judge that at this stage, but that would potentially be the plan. So yes, as I say, that's what we're going to be doing today. Tomorrow we'll be playing Master System games, just like last week, so hopefully there'll be plenty of fun there, because I've still got quite a lot left that we didn't try last time. So again, if that sounds interesting to you, please join me for that as well. So what time is it? I've got 2 more minutes yet before 5:15, so I'll just say good morning to the people who've already joined the chat. Good morning, Mark. Very kind of you to join me this morning. And hello, Leo there. It's again also very kind of you to join me for this early morning programming stream. You just have a sip of tea here. There you go. Sorry. Right, so as I say, we'll be looking at the game, trying to pad it out a little bit. I'll just let you know what state it ended up in last week. We've got a player that moves around, some enemies that move around, and we've got some crystals we can collect. So I think the plan for today is I want to try and make some changes to the code to try and make the movement a bit smoother. I also want to maybe start adding some levels and maybe a second enemy type or something. I am not quite sure. But we'll see how it goes, because you can never predict what's going to happen, because the only time I work on this project is during these live streams. So I'm working on tutorials during the rest of the week. So there's not any pre-preparation for these streams, so anything could happen in the next half an hour, as they used to say on the I think it was the Thunderbirds or something. But as I say, we'll just have to see how it goes, and hopefully some productive work will be done, but that cannot be assured, so we'll just have to see. Okay, well it's close enough to 5:15. I think we can make a start now, so let's go over to the programming. Oh, hello there, and here it is. So this is the program as it currently stands. So we'll be looking at this today. Let's just compile it up. I'm using F9, not F5 on WinApe, so that always catches me out, because I'm so used to my Notepad++, but it is faster to work on this machine. So so you can see here, we can move around and we can increase our acceleration. We've got to pick up these crystals here. So that's what we have to do. Now, hello Z80, Z80 indeed, Luke. Sorry, Luke, I misread your name there, apologise. Yes, we're back on Z80. We're back on this little Yquest game. Now, the thing that, it's not a problem, but the thing I want to try and improve on is, if you see, basically, we're moving in 8x8 blocks, I believe, here. I think we are. So I want to have a look. Or actually, I want to try and move this down to moving 2x2 blocks. So I'm going to have a look at the code, and I'm going to try and resolve that. Just have a look at it and try and remind myself how it works, and see if we can get a little bit smoother movement. Now, on the CPC, each byte has 4 pixels, and I'm not going to deal with half bytes, so we can only move in 4 pixel blocks in display terms, but there's no reason we can't calculate internally in 1 pixel blocks and just sort of smooth it out and just sort of average it for the display routines, and that will allow sort of smoother movement. Hello there, Yellow Belly. Very kind of you to join me. We're doing some assembly programming on the old Amstrad CPC here, so hopefully that will be interesting. It was good fun watching your stream the other day, seeing that the C64 video with the RGB mode. It's a bit of a shock for someone like me, who's an Amstrad user, to see the C64 looking more like the Amstrad. So I will. I mean, there's a sort of temptation in me to say it looked better, but that would be unfair because, as I say, the truth is that it just looks more like I would expect it to. Expect the Amstrad to. So, as I say, the better is a totally biased judgment there. But as I say, I did enjoy seeing that. It's very good. CPC guy yourself. Well, as I say, I think you get the C64 fans who say the C64 looks better because of the pastel palette, and the Amstrad fans say the Amstrad looks better because of the very bright palette. And of course, both are correct and both are wrong. If you see what I mean, it's just that people have created their own judgments based on their own preference, and that tends to be really what they're used to. So let's have a look here, up and down. So we're moving. Okay, so we're moving in 4s here. So we aren't actually moving in blocks of 8. We're moving blocks of 4. But I'm going to reduce this down to blocks of 2. Now the reason for that is the screen on the CPC is let me get this right. It's 80 bytes wide. And it's 200 pixels tall, because of course you can move in one line, but you can only, if you're working in bytes, you can only move in 1 byte. Now I'm currently working in 4 pixel vertical lines when I'm moving my character down, but I could do that much less. But what I want to do is I want to make sure the X and Y axes only use a single byte. The reason for that is firstly speed, because this is an 8-bit machine. It works in bytes very easily and works in words not so well. And the second thing is sort of just convenience. Again, the programming commands for increase, inc and dec and things, add and sub, they all work in bytes more easily than anything else. So keeping things to a byte is going to make my programming job a lot easier all around. But as I say, just because we can't work in pixels, we can work in pairs of pixels, and we can still stay within those boundaries, and hopefully that will be better. So what I'm going to do is I'm going to change sub and add to sub 2 and add 2 here. And where's HL being loaded here? I can't see it. I cannot see it. Oh, player acceleration Y, here it is. Okay, oh, sorry, it's actually been in there. So what I'm going to do is you can see that these are inc and dec commands for the left and right, but what I'm actually going to do with these is I'm going to do these as a sub 2 and an add 2 as well. And then what I'm going to do after this is I'm going to change the drawing code so that the drawing code is effectively halving the X position before it draws to the screen. So it's effectively converting the current pixel pairs coordinates into a byte coordinate. I don't know if that makes sense. I explained it. Hopefully, if it doesn't, don't worry about it. But as I say, I'm working in coordinates that are related to a 256 to 256 range, but then I've got to convert them up into a byte range for the horizontal axis. So where is load A, X pause there, yeah, acceleration, last X pause, blah 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 blah. Draw both. So what I want to do is I want to do a oh god, my eyes are tired. SLA, no, that's not SRL of B here. So that will effectively halve this X coordinate, and that will and as I say, my current X coordinate is in pairs of pixels, but I can't draw in pixels, I've got to draw in bytes. So by halving it, I'm converting pairs of pixels to quadruple pixels, if that's definitely not a word, into quartets of pixels maybe. Anyway, and that will be effectively bytes. So hopefully, let's just compile this. And I would have probably made some horrendous mistake in that code, so let's see what happens. Maybe not. So now we've got the ability for our little Y to move a bit smoother, and our enemies are kind of drundling around there. Again, I think I'm inventing words with that phrase, but that's what I'm using. So they're kind of lurking around a little bit passively, not really much of a threat to anyone, which is what we want for the first level. I'm sorry, I'm just looking at the movement here. It seems a little bit, I don't know, it feels like some of the joy presses are being missed. Okay, right, well, what will we do now, I wonder? Well, we'll keep the, I'm just wondering whether to speed the code up to compensate. Well, let's try it. Let's just, I mean, it's worth a shot. Let's see what happens. I don't know if it's going to make the controls over out of control, or if it's going to make things better. I'm wondering if the delay loops are why it felt like some of my button presses were being missed. I'm wondering if the delay loop is too large, and maybe that's why. So that's something we maybe need to look at a little bit. So let's have a look at that, and we'll see what difference that makes. So here's our pause here. That's a very big pause. So let's try this as 5,000. Because we've now effectively doubled, effectively doubled the precision of our movement. So if we wanted the game to play the same, we would halve the speed of our delay. Still getting this thing. Sometimes I'm pressing the button and the direction isn't moving. I'm wondering if that's, to say, that delay swallowing the, if I press the key and release the key during the delay, I'm guessing maybe it's being absorbed, it's being sort of being missed. So I mean, I can change that in, I could be reading the joystick the whole of the delay, and if there's any press, I could then process the last press during the next loop. That would certainly be a solution to that. Okay, so anyway, let's have a think. What's going on there? That's very weird. Oh, I know what's going on. I've changed my coordinate system, and I haven't changed the size of the code that tests the screen size. So that's why I'm bouncing off the middle of the screen there. I thought there was a bug in the joystick routine there. Okay, well that was just me being dumb. Where's the code that does that? Okay, so where is it? 200 minus 8. That's still okay. So this needs to now be 160 minus, I guess, 4, because we've doubled both of the coordinates. So internally our code is working on a 160 by 200 range, and as I say, the reason for that is okay, that's not right. I bounced too early there. Take that off here. I think that probably needs to just be -1, but we'll try that. Yeah, that's just too large. It's a -1. Would that be -2? I think it'd be -1 because you're comparing to less than. So I think that'll be right there. There we go. That's how it's supposed to behave. Okay, so now, as I say, the controls feel like they're not as good as they should be, and my thinking, which could be completely wrong, but my thinking is that the problem is that the loop, the presses that occur during the pause are just being ignored. So let's take our pause out here, and let's take this and let's move it all the way up the top to, where is it? I can't, too tired at this time in the morning, too tired for programming. Okay, so here's the get joystick routine, and so we're going to do, so here we're going to have our loop, and we're going to do load BC, something like 500. It's going to be quite small now because we're going to be calling the joystick reading routine all through this loop. And what I'm going to do is I'm going to load D with 0, and at this point I need to know whether this joystick routine is going to be changing D and BC for that matter. So I'm going to assume it is. It probably is. Don't trust those firmware routines, they mess with everything. So we'll do push BC, pop DE. We're definitely going to need this loop to be small. all this pushing popping slows things down quite a lot. So yeah, we're gonna want to keep all of that, all of this looping to a minimum here. So this is going to return in the accumulator a joystick press. Now, so we'll do an OR here just to check that the flags are updated, and then we'll do a JRZ, no pause, no key. So no key has been pressed here. If a key has been pressed though, I'm going to load it into D. What's that doing down there? That needs now to be here. And then here I'm going to do load A with D. So what we're doing here is we're pausing for BC. We're reading in from our joystick during the pause, and if there are no keys pressed, then we just leave D unchanged. But if any point at during this pause a key is pressed, we store it in D here. And the result of this should be that if we press 2 keys, then the last will be remembered. But if we just press 1 key, then that 1 key will be remembered after the loop, because before, if the key was pressed and released during the loop, then it would have been totally ignored. And it's my guess that that's what was going wrong, because some of my key presses were being ignored. And this game needs to have nice, smooth controls here. Although it doesn't seem to actually still be working right. It should be moving there. Now that's going to the right, and then if I press left once it should stop, and if I press left again once but it missed one there. I pressed right and it didn't change direction. Wait a minute, let's just check it's not my joypad or the emulator. Yeah, that's fine. Okay, well, I'm going to have a think about that. Hang on a minute, jump Z. Let's just check something here. I can't remember if this works when the keys are, whether this is returning zeros or non-zeros. I think the firmware routine returns zeros, which is the opposite of what my routines do. The hardware itself returns 1 when the keys aren't pressed, to the code. So I'm a little bit surprised that we're missing keys here. Anyway, we'll have a think about that for later. I don't want to get too fixed on that just yet, because the code's going to change a lot and we'll maybe have other more pressing problems to deal with. So anyway, we've improved the precision of the movement now. We need to have a look at the randomization routines, the randomize object position here. and we need to change these because this is now going to be 7F, which again, this is the screen size and this is the random code to select the new position of the enemies, because of course we need them to cover the entire screen now that we've effectively changed the screen size. The other thing I need to do, because it's already causing me problems, is I need to centralize the player at the start of the game. So let's find, here's the definitions for the player position, because the players are currently appearing up the top left and so are the enemies, so that's not good. So let's change this to 80 and let's change it to 100. So, well, actually that's not right, is it? It should be decimal 80. 160 wide. We don't need that breakpoint anymore. Okay, let's just compile this. Got some mess on our screen because someone forgot to reboot, to reset. Now, one thing to bear in mind if you're doing code programming on the Amstrad CPC, if you're not familiar with the system, when you're compiling straight into the assembler, but the CPU is still running, and so if in some cases your code will crash because you know, the program counters ended up somewhere weird, and in other cases it won't. So just you know, understand that if you've done a recompile like that and your code is now acting very weird, it might be nothing to do with the problem with your code. It might just be that the emulator was still in a certain half-finished state from your last execution of the code. So I need to change the collision detection now because I just went through that, which I expected was the case. This is again because I've changed my coordinate system just a little bit. So we need to correct that, and then once we've done all of this work on the coordinate system, we'll be in a position, this needs to be 80 as well, I'll be in a position to be able to actually start making a new enemy type, because I wanted to increase the precision of the current enemy and make the current enemy very slow. So we've got, you know, something to add later that's a bit fast, you know, a bit more menacing, a bit faster. So that's why I've been doing that. So, okay, let's, I was looking for the collision. Here it is. So we need to change this to 2 and 4, I think. Yeah, because as I say, our pixel size is 8 by 8, but we're working in effectively pairs of pixels when it comes to coordinates within the software itself. Okay, so that wasn't a real, that was, oh, it's done. Hang on a minute, let's just to say I'm kind of running old code there, so let's just reset here. That looked about right. Yeah, I think that's okay. So there we go. So we can collect our crystals now. So I think we need to get a bit artistic at this point. I think we need to have a look at our sprites, and we need to make something, some horrendous new menacing enemy that's going to be moving a bit faster around the screen than those floppy-eared whatever they are. I don't know what they are. Don't ask me. I only drew them. So we'll load a Packer sprite editor here, if we can. Yes, we can. We have to be very hopeful that Windows 10 is playing nice, which it does seem to be today. We'll load in our Yquest sprites. So you can see here, this is our player, this is our thing, whatever it is, and this is our crystal. So, I mean, maybe we should reorganize these so that the enemies are all in a consecutive chain. That would make our coding a little bit easier potentially, but for now we'll overlook it. We'll not worry about that too much. So what do we want our next enemy to look like? Hello there, HH. It's evening for you, is it? It's morning for me. hope you're having a good evening then. Hope you're not quite as tired as I am. So I'm going to make this one look a little bit like a crab, I think. It'd be nice to have a kind of crab thing. It'd be nice, but maybe screen space is too limited for that. So we'll see what we can do here. Some kind of pincers here. And let's have a face again. Some eyes. And some kind of blobby body. It's kind of square there. I don't know if I like that or not. Wasn't what I was expecting. But yeah, 8 by 8 pixels. We don't have a whole lot to work with. That'll do. I think that will do. Okay, next sprite. Okay, so we're working in banks, aren't we? Okay. If we go to view and overlay last frame, okay, you see here we can now see our last sprite, and we can now change it. So how will we change it? Well, maybe I was going to make them like pincers, but maybe they could be like a spinning claw, like a robot claw or something. Might work, and because that'll give us some more space here. Let's make its mouth bigger, and let's see what we can do here. Big gobby mouth. There we go. I'm getting error messages. What have I done wrong here? That's not very good. Where have I gone wrong here? It says I'm in bank 1, so why have I got problems here? Sprite 1, bank 1. I need to have a look at the source. I don't know if this is an old version of Yquest editor, but I'm getting error messages here. And all my sprites have vanished. I don't know why. I don't know if that's just a display problem. There they are. It's because I'm in sprite 0. Okay. Oh, I know what it is. It's because I'm using the overlay. It's trying to overlay bank -1 over bank 0. So it's the overlay. I very rarely use this overlay code. That's why a bug's managed to stay in it. So it's trying to overlay a non-existent bank over the current bank. So I need to try and remember to fix that bug, which won't happen because I think it happened last week and I forgot. So anyway, excuse my lousy memory there. Okay, so anyway, let's view overlay last frame again, and we need to draw. Now the alternative to redrawing here, I can't. Yquest editor doesn't have particularly good copy paste options, so I could load this into something like Critter or Critter if it's pronounced like that, and then copy the first frame over the third frame, but I don't want to be messing around with multiple applications, so it's going to be quicker to just redraw this, I think. And then once again, our big mouthed sprite here. So it's only going to be, I've got 4 banks of sprites for 4 frames of animation. Well, maybe we could just have it like its little pincers go in a little bit. Maybe that'll have some benefit and just show off that we do actually have 4 banks. Now the plan is for the 4 banks to be used on a system like this, but on a more limited system like maybe the computer's links, maybe we'll just drop one of those banks, a pair of those banks, so just use 2 banks or even 1 bank. Having multiple banks of sprites like this does allow for an easy way of making a game that looks a little bit better on a decent system like well, that's not the right word, a more memory spare system, should we say, like the Amstrad CPC. But if we're trying to aim for very, very low targets like the computer's links, which just has 16K, or a system like the Atari 800, which is of course 6502, where I think maybe some of the ROMs are only 8K, so sometimes we have to start paring things down to get our program running. And as I say, having multiple banks of sprites gives us an easy way of having something we can turn off to make the game simpler without actually reducing the gameplay, which is the priority in an 8-bit game. The graphics, if we can have nice graphics, we'll have them. But if memory's a little bit limited, then we've still got something we can just scale back, and we can still have all of the gameplay, and we're just sacrificing a little bit of game graphics instead. So let's save raw 8x8 tiles here. And this is going to be CPC Yquest. We want to replace that. And we want to go to the next bank. And we need to do Z80 Amstrad CPC file. Save CPC Yquest 2. Next bank again. I'm afraid there's no automated option to do this, so I'm having to do it manually. I'm not quite sure how we would. It'd be a bit of a pain to automate it because a lot of these options are different actual code doing the exporting work. So to make them all able to export multiple banks would be a bit of a pain. Honestly, some of them don't even export multiple sprites yet. I could spend a lifetime working on Echo Sprite Editor, but I don't. So it's not always the best that it could be. I have to be honest there. Yeah, as I say, it's something that has kind of sprawled beyond its original scale. We don't need that test sprite anymore. Let's get rid of that. That's just a waste of memory then. So we will add an extra enemy here. So this should be at offset 48 here. Another thing I maybe need to do is change this from, instead of using a memory address of the sprite, to using a sprite number and then multiplying by 16, because there's 16 bytes per sprite, and that would give me the memory address, and it would only use a single byte of the definitions here. That would probably be a good idea. That's probably something that's coming fairly soon, I think. Maybe today, maybe not. We'll have to see. I'll have to leave you in suspense for that one. There he is. There's our wiggly claw thing. I don't know what it is. Anyway, you can see it's trundling along as well with its wiggly claws and its big gobby mouth. Now, the only thing is, of course, it's moving with the same rules as the other sprite because we've not done any work on that. Okay, so let's just attempting to engage my brain here. It's kind of refusing, I'll be honest. So let's get this sprite thing over and done with. Let's sort it out. So let's do a dB of 1 here, and so I'm going to declare this to be sprite 1, 2, 3, 4. That's how we're going to do things. So let's just move that out of the way onto my, so just off your screen there. So this is going to be sprite 1 here, and then because we've replaced a word, we need a second byte here just to keep everything nice and working. And so this will now be sprite 2. Yes, it'll be sprite 2. Sorry, for some reason I was thinking in 8. 16 because it's 8 lines, 2 bytes per line, and so this will be number 4, and this will be number 3. And all of these will also be number 3. Now 0 is going to be declared to be no sprite. That's why I'm starting from 1, not 0. I mean, it's you know, it's up to you how you deal with these things. You know, you could start from 0 and use something else to define the objects that aren't to be drawn. This needs to be 6 now as well. But as I say, I'm choosing to use a sprite of 0 to be a sprite that's not visible on the screen. But as I say, that's just my personal preference in this case. So let's just have a look down here. I'm just reading all of the code here. So here we're reading in the sprite address here, and we're adding the sprite frame here. So at this point I need to change this. So E needs to be loaded, D needs to be 0. We then need to do a deck of, okay, hang on a minute. So I need to do a deck of E. Okay, no, that's fine. I'm just trying to remember how this code's working. Okay, so we're working in 256 byte chunks. Each bank is 256 bytes, so we're adding the sprite frame to the top part of the address. That's fine. That's okay. So we're decreasing by E, but then we need to multiply the resulting E by 16. So our best way to do that is to actually load D and then do a rotate. Let me get these things right here. We want to do SR. It's terrible how tired I am here. I'm struggling to read this. SRL of D, and then an RR of E. So that will push one bit out of D into E, and that works. So we're loading in at essentially the 256 value here, and that will become 128, then that will become 64, then that will become 32, and then that will become 16. I don't think that's actually, has that actually 248, 16. I don't think that's actually saved as any 128, 64, 32. That's not actually saved as anything. I thought loading it into D would be slightly faster than loading it into E, but it wasn't. Never mind. Anyway, I don't think we've wasted any resources. And I've got an error here. Jump out of range because I've now added too much code. This does happen. You generally want to try and use JRs where you can, but often you can't. So in that case, we couldn't. That's not good. I've obviously done something horrifically wrong there. Okay. Oh, I know what I've done wrong. I've not added the offset for the sprite banks because originally we were pointing to the whole sprite data, and now what I've just done there is just an offset. So how are we going to do things? Okay, so we're loading B and C here, so B and C aren't in use. Let's see what commands we've got for this. Add Right, yeah, we can only add to HL. That's a shame. Okay. Is our data aligned? If we aligned this, we'd have a much better life. It'd be much easier, but it's not, and I don't want to rely on that because it will it'll cause us trouble. It'll take more memory up, and as I say, on some of these systems we may be very, very short of memory. So what I'm going to do is that's in the wrong place for starters. That should be all the way up here. Tabs. And we need to load BC with sprite data. And then we need to do ext, HL. Just thinking through. Do I want to? The alternative would be to do this with an ADC. We'll do it this way. It's easier. It's easier to read anyway, even if it's not very efficient. We'll do it this way. This could be optimized. You could use the accumulator here, and then you could split sprite data up into two parts: a high part and a low part. The only reason I'm not doing, and then add them to the two components separately, rather than doing this 16-bit add here. The only reason I'm not doing that is the commands you can use you can use remainder division commands within VASM, but WinApe I don't think supports them. So the commands I would use for VASM and the commands I would use for WinApe would be very different, and so I think I'm going to be better off just keeping it dumb and simple here. Yeah, this is only going to be a very small game. And it's going to be a tutorial, of course, so I'm not trying to squeeze every bite out of it. I am going to, where there's a choice of doing something a little bit simply or doing something very, very efficiently but hard to read, I am going to... Good God, what the hell is going on there? I am going to favour the simple route. Okay. I have no idea why that was happening. Is it because I changed BC? BC is being reloaded in here, so I wouldn't have thought so. Swapping HL back in here, and sprite data is the start of my data bank. What am I doing wrong here? My brain is clearly not working properly this morning. So I'm loading in the low byte, which would be the first of the pair. Let's have another look and see what on earth was going on there. Well, the wrong sprite numbers are being used for starters. Ironically, my player sprite is actually moving around okay. And it's being animated correctly. And one would have to suspect that's because it's the first sprite in the bank. Now, I don't know why that wiggly guy's okay as well. That's quite surprising. Okay, well, maybe there's something I'm forgetting about this code. It has been a little bit of a while here. Oh, okay, no, that's why. That should have been remmed out. So my entire data bank was all over the place there. So that's not going to go well. There we go. That's what we wanted. So we've changed now, and so essentially, just to keep everything nice and neat, I need to change these. So this is now unused. and this is now spur num, and 1 equals first. Okay, so save that. So yeah, one thing I do have to warn everyone who is using WinApe and isn't familiar with it, unlike Vasm, which saves every time you compile, WinApe does not save. So don't spend 4 hours working. Be very happy with your work. Click the close button, and then you get a crash and you've lost 4 hours of work, because you can sulk all you want. It was kind of your own fault. So as I say, just bear that in mind if you're using using WinApe, and especially if you're used to Vasm or something like that. They don't work the same, so don't think they will. Okay. I'm trying to remember, how were we defining that an object was no longer on the screen? I thought we were using a memory address of 0 for the sprite. Okay, no we weren't. We were using a collision program of 255. Oh. Okay, well that's the thing. Why did I think we were using a memory address of 0? I'm sure we were at one point. Okay, well, okay, if we're using the collision program to detect a 0, then we will start our sprites at 0 then. So let's take our deck D here out, and I mean, it kind of doesn't matter. I'd clearly forgotten how the code worked though. So this will now be sprite 0. And this will now be sprite 1. This will be sprite 3, and this will be sprite 2. Now, actually, thinking about it, we can change this. So just bear with me a moment. Something's gone wrong here. These should all be 2 as well. So I'm just looking at my code here. So crystal 2, the sprite 2 is the crystal. Sprite 3 is our fast moving enemy, and actually we don't need to change any code to make that enemy faster. We just need to change the data here and increase the acceleration, and that will make our crabby guy a little bit faster. Well, quite double the speed actually. There you go. So he's stomping around like a lunatic now. So that's what his prerogative is. I'm just thinking. Okay. Oh no, go away. Leave me alone. Okay. Now, what I want to do next is I want to change the randomization code, because if I make an enemy change direction less often, unlike the current enemies are changing direction so often, they're ending up quite they're quite static if you think of the entire screen, if that makes sense. If they change direction very rarely, they'd be bouncing around the entire screen, whereas if they change direction very often, they're kind of just trundling around a little territory. So let's see if we can make that happen. So let's change his logic code, which is this one here. We'll change this to 2. And we need to create a new program. Yeah, I'm just poorly documented here. It's all going to get, eventually it will be generated. All of the objects will be generated by some kind of level definition, so there'll be multiple levels of the game, and so the first level may have one enemy on it, and it will just be the slow green guy, the slow purple guy. And then the next level may have 3 enemies, and there'll be all the slow purple guy. And then the next one will have 2 slow purple guys and 1 green guy. And then the final level will have 10,000. You know what I mean? So as I say, there'll be some kind of crude level definition which will define what the attributes of each level are. Hello, Jesus. Very kind of you to join this morning. We're doing a little bit of Z80 programming on the Yquest, which, as I've said before, is starting on the good old Amstrad CPC, but the plan is for it to be expanded to all of the systems currently covered in my tutorials on the Z80. And I would love to port it to the 6502, 68000s later on as well. I just can't quite guarantee that at this stage because I never know what's coming for the future. So as I say, that's what the plan is. So if you're thinking, oh, this looks a bit of fun, but this isn't my Z80 system of choice, or the Z80 isn't my system of choice, then hopefully it's still going to be a little bit interesting to you, because hopefully once we have a game that we're happy with the rules of, hopefully it'll come to the systems that everyone enjoys. That's the plan. Making a nice simple little game like this is I think it's a good thing for people who are learning assembly, or people who are just hobbyist programmers in general. I think it's a good, you don't want to be creating some crazy monstrous giant game that's going to take you the rest of your life. You just want to create something you can look at and say, I did something that was pretty good there, and is going to give you the satisfaction, but isn't going to take you the half your life, because unfortunately it's not necessarily going to produce results even if you did. So our program code is very simple here. So if there's no program, right, so if there's no program, we're just going over to here, and then if program is 1, and then program 1. Now there is a trick here. We could actually do a dec of 8 just to save a byte. That's a 2-byte command. But if we decrease, if A is 1 and we decrease A with dec A, then it will become 0, and that would have the same effect for this kind of loop, for this kind of case statement where we're looking at every possible parameter. But again, it would make the code a bit more confusing. So unless I have to really squeeze every byte out of this, as I say, this is planned to become a tutorial. So let's keep things nice and simple as possible. Okay, so I'm just trying to think what I need to do here. So the program 2 is also going to do a random, but it's going to have a broader number of bits that it's going to be required to be 0 before it's going to change the code. Program so there we go, and then here we need to chance of direction change, so that this part of the random number is the probability the direction is going to change, and then the bottom 2 bits of the random number are whether the x is going to change or whether the y is going to change. So we're using one random byte here for both purposes, and I've put CP1 there. That should be CP2. That's not going to work very well. So there we go, and if I just compile again, is he behaving any differently? I'm not sure he is. It's difficult to tell. Okay, well, we can just go completely crazy, and that will allow us to very easily tell if... let's do that. That should almost never change direction. Okay, well, I think that's actually okay. He's certain. Well, so I was expecting him to really just be bouncing around the sides with that one. Okay, well, let's just put that in there. Let's do... If we put a breakpoint in, we'll be able to easily yeah, okay, so it is running then. Okay. Oh, didn't mean to do that. Oh dear, what's happened there? How did I manage to break the palette code with the breakpoint? Stop it! You're not welcome. Go away. Dear me. Dear me. That was a mess. Okay, so anyway, everything's working okay. That's nice. So, well, I guess it's working. I was expecting him to continue on far longer paths than that. Far longer. But I guess not. Well, okay, let's just... I mean, my random number generation isn't perfect, to be honest, so maybe it's just the result of that. I'm still very surprised by how much he's changing direction. Now, the direction changes when he gets to the... Oh. I don't think I should have survived that. Okay, well, I guess my player collision code is out of whack. Okay. Let's have a look. There's some object collision. This is the code we need to check here. This is the bit. Whenever you press escape, Winate puts that weird character onto the screen. Okay, well, I thought that was okay. Anyway, right, okay, so let's have a think about what we want to do next. Okay, right, well, I think the first thing we want to do is we want to, I think we need to update, increase the number of objects that we have in the game. We need to support maybe 20 objects. Now, for simplicity's sake, so we've got 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's see what that looks like. I'm not quite sure what I want to do yet, so I'm just going to play around with some different settings and see how they go. I want to keep the number of objects as low as possible because I don't want to slow the machines down. But I want to have... Leave me alone. But I want to have lots of stuff so that the game... so that I can have some hectic levels later on. Okay, so that looks interesting. Now I've realised there's something missing. We're supposed to have mines. The game has mines in it, or something that effectively is a mine. They don't move. They're just completely static. You can't touch them. They don't move and they don't kill you. They don't move and they kill you. So and they were a big part of the game. So we gotta do something like that. So I don't think 20 is actually enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I'm going to try for 40. Let's try for 40 and see how that goes. It might go slowly, might go very slowly. But as I say, thinking about the mines, 40 moving enemies is absurd. But thinking about the mines, I think that's what we need. I think. Okay. Yeah, you know, not for the first few levels, certainly not. But you know, thinking about how far do we want this game to be able to go? You know, what's the final level of the game going to look like? For example, you want it to be crazy. You want it to be, you know, you want the game engine to have enough potential. You know, that you're holding back a little bit or an awful lot in the early levels, and then you know you can completely let go and give the player hell on the last level. I don't know if the original game had an end. Used to play it an awful lot, and you know it kept bringing out new levels. You'd get to the level you thought was impossible, and then 3 days later you'd have beaten it, and then 3 days later you'd have beaten that level as well, the next level as well, and you know, so it always seemed to have something else waiting in the wings to surprise you. So I don't know if the original ever finished. It must have at some point started repeating, or at least not producing new enemy types, but it had an incredible number of levels and enemy types, so who knows. But as I say, I want my game to have the potential to you know have a lot of stuff that could come out later on. So okay, so that's what we're going to do here. Very good. Okay, so that's any more than 40 is going to just be absolutely absurd. So that's what we're going to target. We're going to target 40 objects on screen. That could be 40 moving enemies like you just saw, or 40 static mines, which we haven't made yet. So that's what we're going to do just now. So we're going to draw our mine, and we're going to draw it just here. And okay, so we want some kind of mine, and I'm going to be thinking of those kind of naval mines. I don't know what obviously no expert on mine technology, but I'm thinking we want it to look like a big spiky ball, as best we can do within this tiny little sprite. So how does that look? I'm not sure it looks right. We'll go with it for now. So okay, I'm not quite sure what we can do here with such a limited amount of screen space, but that's not really working for me. Okay, change of plan. So we'll just have four. We'll just have 4 spikes, and we'll have them spin around. think you know, what would work at 16 by 16, I think it's going to be different, but we're not working at 16 by 16, so we've got to work within our limitations here, our pixel and our artistic ones, and I think it's possibly the artistic ones are the more challenging problem for me at this stage, but anyway, we'll figure something out. Looks okay. So there's the first one. And then if we move to here and if we put in some spikes just like this, maybe that's gonna look okay. Yeah, okay, maybe. It's just so it's not really a mine, is it? It's more like a rotating that's not looking at all good, is it? It's not looking good. Right, I've made the blades go the wrong way. 1, 2. Yeah, so that needs to be there. That needs to be there. That needs to be there. And that needs to be there. That's next. Okay. I need to fix that bug in the sprite editor, the one where showing the previous frame is messing things up. I think this needs to be here instead. Or possibly needs to be hard on the diagonal, I don't know. Maybe I should have done this in Critter. So using Critter does is far better than Sprite editor. Often I just paste data in once I've done it. Well, 1, 2, 1, 2, 3. Well, it's sort of okay. Well, we'll dump it out and we'll see how it looks. Yeah, we can always change things later on if we're not happy. Yquest, yes. Better remember to save our sprites here. We save sprites here. Do next bank. Z80 Amstrad file. Yquest 2. Next bank. Z80 Amstrad. Oh, Z80 Amstrad file. 8x8 Yquest 3. And if we do next bank again, file, no, it's Z80 Amstrad file Yquest 4. Okay, and that will do that very nicely. And if we now just recompile our code here, well, I guess we need to actually put some test sprites in here. And if we change this to, 4, I think it is, and if we change the acceleration to 0, that should give us one sprite on the screen. And there it is. Okay. But that does immediately cause the problem that I was... Oh dear, we've got a crash. What's crashed? Oh, live 0. No, that's not a crash. That's there's a DI halt on running out of lives. Okay. Now that coincidentally, what happened there was what I was concerned could happen, which is the random number generator is putting a crystal and a mine on top of each other, and as the player we need to get that crystal, but we can't because there's a mine on top of it. So we need to come up with a solution to that, don't we? So what I'm going to do, what am I going to do? What I'm going to do is something. I'm going to do something and it's going to be good. What I'm going to do, I'm not quite sure of yet. Okay, so we're going to create a new program called range test. Range test here. And we're going to do a return here. And we're not going to do any of this. And we're not going to do any of this. We're just going to do here collided. So what we're going to do here is we're going to test if two objects are on top of each other, and one object's position is going to be in let's say, well, it's going to be H, L, B, C or D, E, isn't it? Let's use D and let's use D and B, C. See if object was DE hits object BC, and we're going to use D as X and E as Y. So we're going to load in the D pos here, and we're going to compare to the B pos, and then we're going to add for and compare to the B pos again, and then we're going to load in the E pos, and we're going to subtract 4, and then we're going to compare to the C pos, and we're going to add 8 compared to the C pos. Okay. Now here we're going to do an OR of A, and this clears the carry, and here we're going to do, is it, I forget the command, is it, it's not sec, is it? That's 6502 SCF. So what we're doing here is we're saying if the object has collided, then we're setting the carry. If the object has not collided, we're clearing the carry. So we can call this function with BC pointing to one object, DE pointing to another object's position, that is, and then run this, and if the carry is set when we return, then we've hit the object we were comparing to. So what we want to do with this, I'm going to put this in a notepad because I will forget it otherwise. So we'll just use a little notepad to remember strings and things that I need to use again later on. So what I'm going to do is when I'm creating the positions of the objects, which we're doing at the start with, coincidentally, this command just here, we're going to actually we're going to actually test that we're not colliding with any other object. So let's put that in my notepad as well. So, okay. Just thinking this through. So we've randomized the object size there, the object position there. And so what I need to do next is I need to load IY with the object array as well. And I need to, let's just get this right here. What do I need to do? What I need to do is I need to load so many registers here. Okay, well, let's load just trying to think this through. This is not so convenient here. So let's load B with 0 here, and we will do a int would no, it's not going to be, it's a pain. Okay, so what we're going to do is we're going to load in C with B, load A with B. Hang on a minute. Sorry, let me get my brain in gear here. Load C with enemies, which is the count, sub the current object B, and then we're going to load C with that, and then we're going to push C here, push BC. There's no command push C, that was stupid. And then we are going to do a pop BC here, and we're going to do dic C and JR NZ test next ob pos. So what we need to do, rather annoyingly, is we need to test every single object in the array with that function we just created, range test. So, and what we need to do is we need to load D from come on, let's get in brain in gear here. We need to load D E from one of these pair. So load D from XPOS and load D from XPOS, E from YPOS, and then we need to load in BC from IY, because we're comparing, and we need to have a push and another push and a pop of BC here, because this is this is a right pain of code here. This is going to do dec C, because we need to start from one lower, and on the first loop we don't want to run this at all, because otherwise we're comparing the object's position to itself, so that's not going to go well. So we would need to do array JRZ sure there's an easier way of doing this. Pause, okay. So if A is 0, we don't want to do this. And if it's not 0, we want to do a dec of A, because we don't want to compare an object to itself, because it will always be at the same position. So that would go badly. Okay, so we do our popper BC here, and then we do JR carry, and we re-randomize. So if we've got a carry, then we've collided with one of the existing objects. So we need to calculate a new position for the object, because the one we just randomly guessed wasn't acceptable. So that's why we're doing that there. And here we're going to do we need this next object pos label here? I can't see it anyway. Anyway, we'll leave it for now. So here we're going to do we have to use BC here? It's not convenient. I think we do. No, we don't. We can use DE. Okay, well, we use DE then. Don't think we're using DE for anything else. But that needs to be IY, because we're using IY here for the second compared object. If that works first time, it will be a miracle. Good God, did it actually work? I think it actually worked. Well, it certainly solved the problem. Okay. Good grief. I'm absolutely staggered. Well, my program is never good enough to make something that complicated work first time. I'm sure there's a bug in it, but we'll come across it in another stream, and I'll probably tear what little hair I have out during that stream. So anyway, so that's by some absolute miracle has actually worked. I am utterly shocked. I'm sure there's a bug in it. If you can spot what's wrong with it, let me know. You know, put a comment after the stream or in the chat. So anyway, so as I say, it hasn't crashed here. It's got to the live 0 halt, so that is good. Okay, well, so it's 6:30 here. It's just past 6:30. So what I'm going to do now is I'm quite chuffed with my little bit of programming there. So what I'm going to do now is I'm going to spend about 20 minutes drawing some more enemies for the game, and that will give us something to work with next time. Now, next time, what we're going to have to do is we're going to have to code the levels, because at the moment we've got that massive mess of objects and enemies and all kinds of crazy crap, which is fine. It looks quite nice, but what we want to actually do is we want to have the first level be quite nice and tame. The second level be a little bit tougher, third level being tougher still, so on and so on. Maybe have 20 levels, and eventually it will look something like that. Probably a lot worse, actually, because we'll have much faster enemies menacing the player. So so that's the plan, but we're going to program those levels in, and we're going to have some kind of level generation, which is going to read in the enemy types and build up the enemies. Will there be a collision animation? I guess we could have the original had an explosion, I think. I guess there could be a yeah, we can do that. We'll draw it now. Why not? So yeah, we'll have some kind of we'll have the players Y. I'm not even sure what the player is. In the original, you were kind of an X in a circle. I did play it on my Worms stream. If you check out the Chibi Akuma's live channel, there was a Worms stream. No, it wasn't Worms. I'm making that up. What was the game I played? It was June. It was the June stream. I've never streamed Worms, so don't go looking for that. It was a June stream. I played I played Yquest for a little while, but if you Google Yquest DOS in the abandonware archives, you will find it. It's, as I say, it's a little game I used to play. I quite enjoy. Used to sort of have a friendly rivalry with the co-worker on that particular game, where we would just sort of see who could get to the highest level, and every day we would compare what level we'd got to the previous day, and it was a bit of a laugh. So I say it was a game that it's one of those kind of games that I found quite relaxing, because it was a tough game and it was challenging, but it was short. So what I say, the worst kind of game for me is the Dune 2 type game, where you spend a good hour, planning things, and then it all falls apart in 10 seconds. Whereas with Yquest, it was firstly, you weren't playing against any kind of real AI as such, and secondly, as I say, it was you could play for 5 minutes and have a good game, and you just move on with the next thing. So I say it just felt like a nice little game to me. But so what I'm doing here is I'm just drawing up some kind of animation for the player being destroyed. Okay, that's unbalanced, so we want some balance. So there we go. So the Y has disappeared, and the circle is kind of vanishing. And what we'll also add is we'll add just a little kind of explosion effect here. I'm no great pixel artist, as I'm sure you already know, so just have to deal with what I can manage here, especially with these tiny, teeny, nasty little sprites. It's a bit of a challenge to draw anything that's particularly clear. So there we go. So that's our player being destroyed, maybe. I suppose we could have a little brighter bit in the middle, maybe. Does that look good? Possibly not, but it's what we've got. So if we go last bank here, last bank, that'll do. That'll do. That's what we got. So that's going to be played as the animation for when the player's been destroyed. The objects themselves, they aren't going to collide off each other, I don't think. I don't think there's any need for them to. The important thing is that that a non-moving enemy doesn't stay permanently on top of a crystal, because you've got to collect the crystals. So that wouldn't work if that happened. Now, for sound, I'm going to use chibi sound again. I want this to be as simple a tutorial as possible. As I say, it's going to be a tutorial, so the game isn't going to be any amazing thing. So I'm going to use chibi sound for the sound again, I think. I don't think that's going to be too difficult to add. I don't think that's going to add too much work for the tutorials. And again, as I say, I think for a game like this, a little bit of sound would be nice, but don't want to be going crazy with synthesized speech or anything silly. So that's what we're going to do, maybe. And so, as I say, the other thing we need to do is the original game had the ability to shoot, and I do think we need to do that. So that's probably going to come up either next week or the week after, because I think that's going to be important. I think we need to get that in there, because that will be a significant part of the game mechanic, because if you can fire back at the enemies, that's very different to if you can't. So we'll create these little blobs here, and if we just go next bank, So this is going to be player fire, and I guess we need to facilitate the enemies firing, because most of the enemies did not fire, but some of them did. So again, I think that's something we want to program in. Now, player fire, I guess, doesn't hurt the player. I guess it won't. But enemy fire will, of course. Player fire will hurt the enemy, and both player and enemy fire will continue until it gets to the end of the screen, and then it will disappear, which is very different from the normal objects. I think we probably want to create the player and enemy fire as a separate object array, because the current object array is handling enemies and it's also handling the crystals. But you don't want to have a situation where the enemy can't shoot because the player's shot too much, and you don't want to have a situation where the player can't shoot because there's too many enemies on screen or something. You want that kind of thing to be consistent. For animation or collision detection, no, I'm not doing that, Rock to 11. You are correct. That would be arguably the correct thing to do. However, for these 8-bit systems, and especially for a simple game here that's intended to be a tutorial, it would be it's excessive to do that. Chibi Akuma's never did that. The only time it became a problem was with the what's it called? The Turbo R, which was much faster system. For as I say, for a game like this, which is just a basic tutorial, then it's excessive. It would make the tutorial more complicated. And for a game like Chibi Akuma's, the game was just running as fast as it possibly could, so there wasn't a case to do that. Say, depending on the kind of game, if you're trying to create a game with very smooth animation at 60 FPS, then there are people who do that kind of thing for 8-bit games, but it doesn't tend to be something you need to worry about on an 8-bit system, because CPU power is usually so limited. It doesn't become a factor, to be honest. The problem is more often that the game is running so slowly. And I'm not talking about my games, I'm talking about commercial games as well. The problem is more often that the game is so slow it's not really playable, than the movement isn't quite as smooth as it could be, or that kind of thing is going on. You would maybe want to do that for 60 Hz, 50 Hz releases, but as I say, even the commercial games in the time didn't tend to make any effort to do that kind of thing. So I'm not going to be using any interrupt handler in this, because it would make the tutorial far too complicated. For one thing, I'm using the firmware for the joystick reading, which I don't personally like doing. Yes, exactly, Rock 11. It would just move. It will move at a fixed speed every redraw, and I will just. There's a very simple delay loop, and if necessary, if there's too few sprites on the screen and it's moving too fast, I will just alter the size of the simple delay. As I say, with the exception of the Turbo R, all of these systems were only ever released at one speed. There's not a here it is. That's my delay loop here. All of these systems were released at just a single speed. The Amstrad CPC was only ever a 3.5 megahertz system. The Sam Coupe was only ever 6 megahertz. It's only the Turbo R, which if you turn into turbo mode, was running at it was running at 8, but it was more like 20 megahertz. It's only that system that that kind of thing comes into play. And as I say, the game you're looking at today, give or take, is what the game is intended to look like. This is never intended to be some amazing arcade. It's never going to be some amazing arcade accurate game. It's just a little simple game that can be used as a template for a tutorial series. So yeah, I'm not going to try and calculate anything particularly beyond this. So yeah, that's just it's just outside of what I'm looking to do with this one. But yeah, it's just going to move at it's going to move basically at a fixed distance per redraw, and I will try and maintain the redraw speed. But as I say, you are correct. If you are if you were working on a system like the 68,000 and you were looking to create a quality game, a proper game on that, shall we say, the 68,000 was released at a very large range of speeds. The original one was 10 megahertz, the final one was 100 megahertz. So having a crude delay on that system is not enough. I even had trouble delaying it using interrupt handler, using the frame redraw. For some reason, I think even that wasn't. I was drawing my frame and then waiting for the frame redraw and thinking, oh well, that'll cap it at 50 frames per second or 60 frames a second. But I think actually the slow one was taking more than one frame to draw everything, and the fast one was taking probably a tenth of a frame. So even then, it wasn't doing it quite right. So yeah, as you say, you would arguably want to do the mathematics within the interrupt handler, but as I say, it's outside of what I'm trying to do. The other thing is I'm only using a single byte for the XY position, so I've got no ability to move half a pixel or anything like that, which you would probably want if you were going to start doing more sort of calculated movements based on the individual frames. So it's not going to be. I'm afraid it's not going to be that advanced. This one, it's just going to be a very simple game. Would be interesting to know. I have no idea, but it'd be interesting to know how many 8-bit games actually did do that of facilitating calculations based on the refresh rate versus how many just ran as fast as they possibly could and moved by 3 pixels per draw. I don't think WinApe's got the ability to do that kind of thing. Simulating a faster processor, because that's what you would effectively be dealing with. I mean, you can increase the speed here. You can just drag this and it will go faster, but that will increase everything. Redraw deltas. You think so? Because Total Eclipse, to my mind, when the game got complex, your movement actually got slower. So the impression I had was the opposite. If there was twice as much, they had to avoid tunneling for collisions. I'm sorry, I don't know what you mean by that. I apologise. So I'm not quite sure what that means. That's not a term I'm familiar with. I'm sorry. I'd say I mean, Total Eclipse was a very impressive game. I wouldn't know where to begin to writing a game like that, but I wasn't aware that when you press the turning buttons and things that your player moved at a different speed if the game was running slower, and I wasn't aware that the enemies would move at different speeds if the frame rate was lower either. I say I'm not sure. Power ports are terrible on this since they slow the games down to match 50 Hz. Well, as I said before, Jesus, that's my opinion. Now, I have to be fair to it. Bubble Bobble, I didn't notice the problem last time I played it on the Sega Master System, because the first time I played it, it felt slow. But this time, maybe it's been long enough I've not played it that I've forgotten. But what I am planning to do is I'm going to do a comparison video at some point. Once we've got the Mark III out, because I've got Bubble Bobble on both, I'm going to prove what's going on, and I will play the Master System version, the PAL Master System version, and I will play the Japanese version, and we'll see what the speed difference is, purely to confirm to myself whether I'm being unfair, going mad, or what. Because as I say, I thought the Master System, I thought the European Master System version was much slower, but I'm probably wrong. I could be wrong, and I want to know for my own sanity. So, as I say, there will definitely be some kind of comparison video where we'll play the two. If an object moves towards a wall and the frame rate is slow enough that on one frame it's on the left of the wall, then there wouldn't be a collision. Yes, but if the object moves, but again, if they're moving everything in, but if they're not making any allowances for the drop in frame rate, then that wouldn't necessarily make it. I see what you're saying. I don't know. I mean, the truth is that I I can't fathom the I can't imagine what the mathematics were working on for a game like that, where you've got such a large world environment working on an 8-bit system. So I can't really make any judgments on how they would deal with that kind of thing. I see what you're saying now. Yes, I understand it'd be a problem. I guess it would depend on how they're doing things internally, mathematically. So if I was able to write a 3D engine on a Z80 system, maybe I could answer that question, but I'm not, because if I was, I'd be doing it. I'd love to write a game engine like that, but as I say, it's just it's beyond my mathematical ability and my programming skill set at this time, and maybe one day it won't be, at which point we'll be doing that at 5 a.m. in the morning. But unfortunately, at the moment, it's that's the kind of thing that I still sit in amazement looking at. As I say, that Freescape engine, absolutely amazing. I mean, I've heard people criticize it because it's slow, but it's like, for God's sake, look what it's doing, man. Look what it's doing on an 8-bit system. So I say very impressive system. But yeah, I do understand what you're saying now. I just can't answer because I don't know. But as I say, yeah, very impressive engine. Just drawing a big old mouth here. Oh, I've done that wrong. But yeah, I mean, as Hazer said, I think the vast majority of 8-bit commercial games even didn't make any attempt to control their movement based on any kind of refresh rate or anything. I think they were typically just running as fast as they could, and even worse than that, even if you were just doing that and just adding a fixed number of units per frame, you still would have the potential to alter the number of units by an amount to compensate for the difference between the PAL and the US version, the PAL and the NTSC version. But I kind of don't think most did. I'm not immediately aware that many did. I mean, I think some probably did use the interrupt handler to some extent to allow the game to stay at a smooth speed, but I also think plenty didn't. But, as I say, in this case, we're just going to be very simple, I'm afraid. Keeping the game engine pretty basic. I don't know what that is, but I think it looks quite funny. It's pulling silly faces. Yeah, I think it needs a tooth though. It needs like one tooth in the middle for comic effect. Give it like one tooth. I think actually it needs to be darker. I'm not sure it's going to look like a tooth then. Anyway, we'll see how it goes. There we go. Well, that's what we've got anyway. I've not done the bullet there. The Yquest Sprite Editor doesn't have the ability to copy from one bank to another, unfortunately. So that's why as I say, I could use Critter to copy. That's what I'd often do, but in this case, I'm just redrawing everything because we've got these simple little 8x8 sprites. I'm just redrawing everything just for simplicity. Well, we are 2 minutes away from 7 o'clock, so I think at this point we're going to have to call the end of this stream. I've had a lot of people here today. I really appreciate it. I hope you've found this interesting in some way. We're going to be coming back next week and continuing on with this programming project. As I've said before, it's currently just a little CPC program, but once when it gets finished, which I'm expecting to be in around a month, I am going to start porting it to other systems. Not sure if we're going to do that in the live streams or if we're going to do that, or if I'll do that offline. I'll have to think about how long it's going to take and how much fun it would be to watch, but that's certainly the plan, to port it to the other Z80s, and then it will become a series of tutorials in its own right. It will essentially become a continuation of the Simple series, because this was based on the Simple series joystick reading routine, and so, as I say, it will actually become some kind of tutorial series. I think it's going to be a new series called like the Games series or something like that, and I'm doing this Yquest game first, and then I'm going to do assuming this goes well, which it is going well, I'm going to do a Tron game, a pixel drawing Tron game, and then I'm probably going to do a Frogger game, which was a suggestion of one of my Patreon backers. They wanted to see a Frogger game, so I started on Yquest parody first, because that was a game that I'm more familiar with. I'm not massively familiar with Frogger. I have played it, but I don't really have in my mind what a good or bad version of that game would be. So that's why I've started with this. But as I say, I think this is making silly little simple games like this and then turning them into tutorials I think it's good for viewers, because they get to see a game that an amateur a game that is a good target for an amateur to attempt to make. You don't want to aim so high you fail and then lose your confidence. Starting for something simpler is possibly going to be best for people. And also, as I say, they're all going to be free, open source, blah blah blah, all that kind of thing. So the game will be available to download, to modify, and whatever you want. And as I say, we'll do a tutorial series which will cover how the game, there'll be like an episode or two on how the game works and how it was built up, and then there will be a tutorial or two on porting it to the other systems. So if you need to know how the game works, you'll be able to watch the first one, and if you need to know how to make a game work on the system of your preference, then there will be the other one. That's the kind of idea I have in my mind, and as I say, that will be a whole series of tutorials later on. So if these live streams are a bit slow for you, or you're sick of seeing me stare at code trying to debug it, you can get all of the goodness from it in the final tutorial series on the main channel. But if you like this kind of what will happen next kind of feeling, then this will be continuing. Anyway, get my thanks for watching page up. Anyway, I hope you've found some amusement in this, watching me fumble along with this. I hope you have a great evening, afternoon or morning, just depending on what territory you're in, because I know I've got people all over the place. I hope you're having a lot of fun with your retro computers and your programming if you're into programming. Whatever you do though, take care now. Thanks for watching today, and goodbye.